Anyway. Okay. So the command to start magic is always mag09. Okay. And when you start magic, you will see two windows. One for writing command and one for drawing the layout. Alright? Now the first thing you do is you enable the toolbar. Okay. So one thing I'd like to explain is this particular technology you'll be working in is 180 nanometer, right? That's quite an old technology. You can't find it in processors anymore. But so the channel length is equal to 180 nanometer, but the channel length is always equal to 2 lambda. All right, we always say that channel length equal to 2 lambda. So what is lambda in that case? 90, right? So this is the unit that you use to. This is the smallest unit you have to control your layout. So this is why the command to start the program is mag09, because lambda is 90. Okay. So you could see here it's 0.09 times 0.09. Okay, so here I just enabled the toolbar on the left side.
So does it mean that if I said mag any other number, it will start with
This is just an alias we've defined with an option to start in 90 nanometer. But I'm not sure if I defined other aliases, but you could do that. Okay. So I'm gonna go ahead and draw an inverter, but first of all, I'm gonna enable the grid. Now in this grid, each unit is lambda by lambda. So this is 90 nanometer by 90 nanometer. Okay. Now I zoom in and out using Z and Shift Z. The first thing you do is you draw the wells, the P well and the N well. Okay. So let me start with drawing the Nmost part. So using the right click and left click, you can control the size of the rectangle. And then, by the way, if you don't have a mouse with a middle click in it, you'd have to get one, because middle clicks are used very heavily in this software. Whenever I want to draw a layer, I just use a middle click. So here I want to draw a layer of a P well for an NMOS. So I just search for a P well layer, which is this, and I middle click on it.
How do you know that?
You could see it's written P well. Okay, so this is the color of a P well. You can disable the grid. You see it? Okay.
So you enable the grid?
Yeah, you just press G to enable the grid. You always have the grid enabled because it makes it easier to draw. Okay, now I'm gonna draw the N diffusion. Okay, now I'm gonna give you a demo of an error you can see in your layout. For instance, I want my diffusion to be of this thickness. You could see there are white dots. This means that you have DRC errors, design rule check errors, meaning you didn't satisfy the minimum distances and minimum width in your layout. So to find an error, by the way, you would just try the command drc find, and it will place the box in your layout on your errors and tell you. So over here it tells you that the distance between a diffusion and the end of the P well should not be less than 6 grids, 6 squares. If you do the RC find again, it will move you to the second error you have. And the RC find again, it will tell you that the diffusion, the thickness of the diffusion should at least be 3 lambdas. So let me fix all of these errors now. Usually, okay, so this is the width of the transit. I'm gonna make it 4 lambdas, and here I have to place more p-well because there should be at least 6 lambdas between the boundaries of the p-well and the boundaries of the diffusion.
Who decided these rules?
These are decided by manufacturing for a certain process. Okay, so I have no more errors. You can check the errors by looking at the DRC field over here. If it's 0 and green, then you're good. Okay, now I'm gonna draw the pulley. So by the way, why did I make the pulley just 2 lambdas thick?
Because the length of channel is 2 lambda?
Yes. So the thickness of pulley should always be 2 over the diffusion, so that the channel length is 2 lambdas. So here you can see I have errors. The pulley should be 3 lambdas on either sides of the diffusion. This is by the rules.
So how do you know?
Magic will tell you whenever you have an error, and with practicing you'll memorize them, and you just, like, once you draw 1 or 2 layouts, you'll memorize them. Or you can just by the way, this is all recorded as a video. I'm gonna post it on YouTube, and you could like review it again and just check these rules. Okay, so this is I've created a transistor now. This is a source or drain, or this is a source or drain because it's symmetric. Okay, now let me draw I'm gonna draw a metal layer. So I selected the metal. Actually, you don't have to select the metal, you just yeah.
What the base? You know, the first time, the first thing you drew something like the base, which is the bigger.
It's a p-well.
So what the base is the body or?
This is the body, yeah. Remember, in an NMOS here, you have p-well.
Okay, so is there anything other than the B well, the N well, for example?
For the PMOS you draw an N well.
For the PMOS?
Yeah.
How big should it be?
It should be at least 6 lambdas on, like, everything should be contained within 6 lambdas of the boundary of the p-well.
And how do you see it? It's 6 lambda?
But it's 6 squares. So if I delete this, it will tell me there's an error here because this is not 6 lambdas. This is 5 lambdas.
But the top of the boundary is not. There are 4 lambda only.
It's from the polysilicon, so it doesn't matter. It counts it from the diffusion. So there are 6. I think it's 7. Yeah, 7. There's an error now for some reason. Anyway, you can undo using U. Yeah.
Is there any document concerning the layout rules?
There are, but I don't know if I can find it. It's somewhere in our labs. But you don't need to have it because like I said, you'll memorize them once you do it in a layout. Okay. So I want to make the contact for the diffusion and for the source and drain. Okay. So what I do is, okay, I don't know what size the contact is because I don't know the rules. So I'm just gonna do it like 2 by 2 and see if it works, right? So I go to the layers. Each contact is a layer, by the way. So you go and search for